Thank you, Claire. So yes, you're finishing with me again, and thank you very much for many of you that have stayed for this final session. No more games, I'm afraid, in this one. I wish I had a little dance for you to help warm you up, but I'm afraid I don't. But what I do have is hopefully a bit more of a thought-provoking presentation and really thinking about what the future might hold for us. So before lunch, more than 95% of you said that you thought we would get GM herbicide-tolerant crops coming in the UK. So based on that, let's just have a little bit of an update on where we currently are with GM. So actually, I think it can sometimes get slightly confusing about what genetic modification is. And I think particularly now where sort of phrases that like sort of biotechnology are talked about a lot, which actually doesn't necessarily mean GM. So biotechnology can be a way where we can use things like the mutation breeding, things like that have been used to develop the Clearfield varieties. So whilst it is actually badged under conventional breeding, biotechnology sometimes includes GM and sometimes it doesn't. So I just sort of wanted to sort of put that out there. So this slide really just shows you some of the differences between sort of what we call sort of more pure genetic modification and then the conventional breeding. So with GM, we can transfer sort of small amounts of DNA into new species, whereas conventional breeding programs, it's generally they're looking on larger amounts of DNA. With GM, the DNA is better characterized, not so much with some of the conventional breeding. But really, I mean, this is the sort of the key difference, and this is the contention point, really, actually. With GM, we can introduce DNA from any source. With conventional breeding, we can only do this through closely related species. And I think that's the sticking point that a lot of people have issues with. The processes by which we achieve this through GM, we use things sort of transformation and tissue culture. You might have heard of sort of the gene gun, where you can blast particles containing sort of DNA that you can introduce into species. And as I mentioned, with conventional breeding now, there are a lot more technologies that are happening, and it can introduce things like using sort of chemical mutagenesis and to develop things like the Clearfield varieties. With GM, the genomic location of the introduced DNA is actually not sort of very well controlled neither. And with conventional breeding, although you're looking at closely related species, a lot of these crosses couldn't actually occur naturally, so we do need this sort of breeding process to develop these sort of newer varieties. So that's just a few of the differences there between them. So what's HGCA been doing? Well, we recently, earlier this year, we commissioned a review which has been conducted by Reading University, and this is an evidence-based review, and this is to look at the likely economic and environmental impact of GM cereals and oilseeds for UK agriculture. And that report will be sort of due by the end of the year. And there's lots of these reports have been done globally. There's not so many that have been done really very much focusing on the UK, and specifically not focusing on our industry, really looking at what this might mean for cereals and oilseeds. And why are we doing this? Well, this really, I mean, HCA is all about providing information and providing evidence. And again, this is no difference. This is to provide evidence that then might feed into future debates. So we're not a political organisation, we're not a lobbying organisation, but if we can provide that evidence and information that we can pass on to our colleagues in, for example, the National Farmers Union, then they're the people that then can take this to Europe and they can get involved at that more political level. So just a few headlines that are coming out of the review from Reading so far. So a little bit about what they've been doing. So within GM oilseed rape, they've so far reviewed 26 separate studies worldwide. Currently, there's 34 million hectares of oilseed rape grown, and 27% of this currently is GM. The main focus for oilseed rape has been on the herbicide-tolerant varieties. There's been evidence to show that the yield increases can be between 6 and 11% with the HG varieties. And the gross margin here has also been increased between $22 and $90 per hectare. There have also been environmental effects. It has allowed for a reduction in herbicide usage, a reduction in carbon emissions, largely because you're not having to work the land so much, so there reduces in diesel usage there. And yes, there have been issues with resistance weeds and superweeds, but overall, it's not been seen that actually volunteers generally have not been a problem, and it's been in more isolated cases. And I think now people are using the GM crops more responsibly. There is more information now provided on actually how you have to sort of rotate your chemistry and how you have to use them responsibly. No different really to how we have to take an attitude to managing things like blackgrass. And if we look at what they've been looking into in GM cereals, at the moment they've reviewed 63 separate studies, and this is mainly focused on wheat, barley and rye, where there's non-commercial crops currently grown. Obviously there is a lot of maize that's commercially grown. Some of the work and the trials that have currently been undertaken on cereals have been looking at, you can split them into pre- and post-harvest traits. So pre-harvest, there's been work done looking at herbicide tolerance, disease tolerance, abiotic stresses and yield. And areas of interest post-harvest have been more around sort of modifying the grain quality, how you might be able to develop industrial enzymes, plant-derived vaccines, and around biofuels. Work that's currently in the pipeline, so within the EU, there's currently sort of 10 field trials on wheat, barley, triticale and maize that's been undertaken. In Australia, there's 15 field trials that are happening, and that's between wheat and barley. And obviously, this is a massive contrast to what's happening in the States, where there's currently 510 applications out there for wheat trials and 109 for barley. So it's a massive difference. So this slide just shows you just an example of currently what's out there within Europe, the countries that are involved in these trials, the crops they're involved in, and actually what the target is there. So we've got things there like sort of low celiac wheat, improved nitrogen use efficiency barley, improved phytase barley, high vitamin maize, a whole range of different things. And as you can see there, and I'm sure you've all heard of this, there's just one field trial that's currently in the UK, and this is at Rothamsted, and this is the aphid alarm wheat. So what are the future global traits of importance? Well, there's quite a lot out there. So things like responding to the abiotic stress resistance. So we're looking here, focusing on things like drought, temperature, the impacts of flooding, salinity, things like nutritional and health benefits. So obviously there's work happening on golden rice. So this can potentially help with vitamin A deficiency. The omega-3 oilseed rape, again, this can be help fight heart disease. Work on the purple tomatoes, which are packed full of anthocyanins, which again can help prevent chronic diseases. There's more work that's of interest around pest and disease resistance. For example, there's been work ongoing on potato blight and on fusarium in wheat. Nitrogen fixing crops, another thing that's on the horizon and could be quite exciting. Traits that will prolong shelf life activity. So a lot of this started off many years ago with a flavour saver tomato, you know, the tomato that was stayed riper for longer. Well, there's something similar now happening with Arctic apples. So when you cut the apples, they won't go brown, they'll stay white for longer. And then there's non-food applications there as well. So things like developments towards fuels and fabrics. And although these are globally important, I think you can also see that actually quite a lot of these could be potentially very helpful within the UK. So a couple of slides now just to give you a bit of a picture, and I'll come back to earlier. This is a slide reviewing the global area of biotech crops. So this includes some of these technologies that are not specifically GM, but actually still where we've been able to alter the gene profile. In 2012, there was 170 million hectares of biotech crops grown globally. And in 2012, for the first time, there's actually more biotech crops grown in the developing countries than in the industrial countries. So a bit of a change there. And maybe it's in some of these countries where actually perhaps a GM technology can really have the biggest impact. Again, if we just look here at the different crops out there, you know, currently there's a huge amount of sort of GM soybean out there. I mean, we may face a point at some point in the future, or actually, you know, we can hardly get hold of non-GM soybean. And oilseed rape, the line across the bottom there in green, you know, it is gradually increasing, but actually it's still less than 25 million acres of biotech oilseed rape that's grown globally. And if we just look at some of the different traits that we've got there, so herbicide tolerance trait has been the trait that obviously has developed the quickest and is now most widely used. But the red line there represents the insect resistant traits, and you can see in 2007 there's a change there now that actually gene stacking's coming in more and more. And there's more crops now that have got the herbicide and the insecticide resistant traits in there than just the insecticide resistant traits alone. And this next photograph just shows you some of the implications of this. So on the left there's a crop there. That's a conventional maize plant, and you can see the root mass there. And you can compare that with the root mass on a GM maize crop, which has actually got the stack gene. So this has got the insect resistance and the herbicide tolerance in there. So you can just see, and maybe this explains perhaps why some of these increasing yields we're getting with some of these GM crops. So what's happening in the UK? Well, we've sort of touched on it a little bit today, and we've sort of heard about this in the past over the last couple of years, work at Rothamsted on this aphid repellent wheat. So this is where they're genetically engineering a wheat plant which produces high levels of this sort of aphid repelling odour, so this aphid alarm pheromone. And this has the benefits of being able to attract natural enemies and also potentially can promote more environmentally friendly agriculture. So could this be a possibility where maybe through environmental benefits could be a route to acceptance of GM technology? There's current work ongoing at the John Innes Centre where they're looking at the purple tomato. So this tomato on the left here is absolutely packed full of anthocyanins, giving it this very deep purple colour. And these have cytotoxicity against cancer cells. And some of the lab trials they've done at JIC, where they've looked at cancer-prone mice, feeding them the purple tomatoes, they've actually extended the lifespan of these cancer-prone mice in comparison to conventional tomatoes. So again, maybe is this something that, would the potential health benefits be a way to go towards GM acceptance in the future? So could this be a tool for the UK? Well, there are some advantages, and this is a list sort of really pulled together from sort of many studies that are out there at the moment, not based on any single one piece of work. There's lots of evidence to show that there are yield increases, that you can reduce your inputs, and obviously as a result of this you can increase farm incomes. We can have health benefits from some of these traits, and we can reduce the impact on non-target organisms. But always with disadvantages, there always comes disadvantages as well. And obviously there's lots of potential problems with that have been reported with weed resistance and pest resistance, I'm sure is going to be along there as well. Lots of concern over corporate dominance. This is one of the big things that people just really don't like this. Concerns over cross-pollination. But actually sort of the biggest sort of impact, and really I think the biggest disadvantage towards acceptance and whether there's a future for this in the UK is really underpinned by public acceptance. And without public acceptance, then this is really not going to be taken up by the supply chain because that market's not going to be there. So potential for reaping the benefits. Well, there is potential there. What it does do, it gives us another tool in the toolbox. And at the moment, we need as many tools as possible if this industry is going to have a future. And we've got to pull everything together that we can. We can increase farm income and production using some of this GM technology. There's a potential to use less land and have better resource use efficiency. There's evidence to show you can get reduced greenhouse gas emissions and lower commodity prices. Actually, this is more of a concern. So really, this is a big figure. So the revenue that's foregone if the EU doesn't adopt some of this technology could be as much as 90 million euros. This is a lot of money we're talking about. There are currently 16 million farmers that cultivate GM crops, which is about 7% of the world's arable land. So I think biotech crops and GM can serve as an engine for rural economic growth, but obviously only if we have the acceptance. There is still quite a lot of support for GM, and it is a bit of a concern that the EU is perhaps being left behind, and maybe this is being putting us very much at an unfair advantage now. I said no dancing, but feel free. But But I think really the real stumbling block, that we come back to, it's kind of this group of people. It is the public. And that public acceptance. And so the Institute of Grocery Distributors, they've been doing surveys over the last sort of decade or so, and this is just some of the results from when they asked this same question about how strongly, if at all, do you support or oppose GM foods, and they did this in 2003, 2008, and then again in 2012. So in 2003, you can see there that the strongly opposed was 17%, the strongly support was just 3%. In 2008, 15% strongly opposed, but still only 3% was strongly support. And really very little difference when we come to 2012. We're now looking at 13% that would strongly oppose, but it's still only 3% that strongly support. And throughout this time, it's been around 50% that neither support nor oppose this technology. So actually, there isn't very much sort of general change out there with public perception. So in conclusion, variety improvement, this is the long-term business, and we have to do everything that we can to achieve this. There is a wide range of untapped genetic variability out there in wild relatives, and some of this can only be accessed through the use of GM. Breeding is still dominated by yield, Simon mentioned earlier, but actually, I think quality is there and quality is coming in, but a lot of this really is dependent on sort of premiums being paid for certain quality markets. I think when GM was introduced, it was certainly seen as a bit of one of the benefits was actually it could reduce the breeding time from taking a new concept through to commercialisation. I'm not sure this is maybe so true anymore. Actually, with some of these new biotechnology approaches and the use of things like double haploid populations and single seed descent, actually we can get conventional breeding now down to around about 7 to 8 years. So we've been able to make some of those savings. And you could argue really that actually maybe GM now is taking longer because by the time you've gone through the approvals process, the registration process, the massive headaches around labelling, actually whilst you might have developed that variety, it still takes longer for that to be on the shelf. I think it's really good news that Monsanto and BASF have reignited their GM wheat breeding programme, but I think it's a real shame that there's no focus in Europe. And I think what is more of concern, whilst some of this exciting science leaves Europe, then actually a lot of the excellent scientists that we have will also leave Europe and they will sort of follow the work. And I think that is a real problem for the EU and down for the UK as well. So a final word, GM is not new. It's approaching sort of 20 years soon, and actually it is here to stay. And I'll finish on that. Thank you. Thank you.